Hello everyone, I've recently picked up C++ again, and in this video, we will see some basic order book and trading related C++ coding. To start with, let's set up a basic order book data structure or struct representing a single order in a trading/order book system. It will have the following fields: ID, a unique integer identifier for the order; price, the order's limit price in floating point; quantity, the number of units to buy or sell, is underscore buy, a Boolean flag indicating side, true for a buy order, false for a sell order, faster and smaller than storing a string. Next, we will create a class order book that uses this struct to set up an order book flow. It will have all the functions needed while creating an order to trade. In the main function, we will create an instance of type order book named book and use it to perform actions. Now let's start building it. At the top of our file, we include the necessary headers. We have iOS stream for input and output streams, string for string operations, map for our order data structures, vector for storing collections of orders, and iomanip for formatting output. First, we define our order struct. This struct has 4 fields as we discussed: ID as an integer, price as a double floating point number, quantity as an integer, and is underscore by as a Boolean. The struct also includes a constructor that takes 4 parameters: I for ID, P for price, Q for quantity, and by for the flag. The constructor uses an initializer list, which is more efficient than assigning values in the constructor body. The syntax uses a colon after the constructor name, followed by member initialization separated by commas. Each member is initialized with the corresponding parameter using the syntax member equals parameter. Next, we define the order book class. This is the core of our trading system. The class has 2 private member variables, bids and asks. Both are maps that associate prices with quantities. The bids map uses a custom comparator std greater of double, which means it sorts prices in descending order, so the highest bid price comes first. This is important because in trading, we want to match the highest buy orders first. The asks map uses the default ascending order, so the lowest sell price comes first, which is what we want for matching sell orders. The order book class has several public methods. The first one is add order, which takes a constant reference to an order object. Inside, we check if the order is a buy order using the eyes underscore buy flag. If it's true, we add the quantity to the bids map at that price level. We use the bracket operator on the map, which automatically creates the entry if it doesn't exist, or adds to it if it does. The plus equals operator adds the new quantity to any existing quantity at that price. If the order is not a buy order, meaning it's a sell order, we do the same for the asks map. The remove order method takes 3 parameters: price as a double, quantity as an integer, and is underscore by as a Boolean. We check if it's a buy order, and if so, we subtract the quantity from the bids map at that price using the minus equals operator. After subtracting, we check if the quantity at that price level is less than or equal to 0. If it is, we use the erase method to remove that price level entirely from the map. We do the same logic for sell orders using the asks map. The getBestBid method is a const method that returns a double. It first checks if the bids map is empty using the empty method. If it is, we return 0.0. Otherwise, we return the first element's price. Since bids is sorted in descending order, the first element accessed with begin and then first gives us the highest bid price. Similarly, getBestAsk checks if asks is empty, returns 0.0 if so, otherwise returns the first element's price, which is the lowest ask price since asks is sorted in ascending order. The getSpread method calculates the bid-ask spread, which is the difference between the best ask and best bid prices. It calls getBestBid and getBestAsk to get the current best prices. If either is 0.0, meaning one side of the book is empty, we return 0.0. Otherwise, we return ask minus bid, which gives us the spread. The print top of book method displays the current state of the order book. It first prints a header using the left shift operator twice with std.count. The \n creates a new line. Then we set the output format to fixed decimal notation with 2 decimal places using std fixed and std set precision with argument 2. We then iterate through the bids map. We use a range-based for loop with structured bindings, where we destructure each map entry into price and quantity. We use auto and ampersand to get a constant reference to each pair. Inside the loop, we check if a counter variable is greater than or equal to 5, and if so, we break out of the loop. This limits our display to the top 5 price levels. We print each price level using the left shift operator, showing the price, the @ symbol, and the quantity, followed by a new line. We do the same for the asks map, resetting the counter to 0 first. Finally, we print the best bid, best ask, and spread values by calling the respective methods. In the main function, we create an order book instance named book. Then we create a vector of order objects, initializing them with specific values. Each order constructor call takes 4 arguments. An ID number, a price, a quantity, and a Boolean for is _by. We have orders with IDs 1 through 5, with various prices and quantities, and a mix of buy and sell orders. We then loop through all orders in the vector using a range-based for loop. We use const order ampersand order to get a constant reference to each order, and we call book.addOrder with that order to add it to the order book. After adding all orders, we call book.print top of book to display the current state. Then we simulate removing an order by calling book.removeOrder with price 123.50, quantity 100, and true for is _by. After removing, we print the order book again to see how it changed. Finally, we return 0 to indicate successful program execution.